Hi and welcome to the next module in the Python short course. It's on testing. So just a quick recap on lesson 2. What did we learn? Well, we looked at variables, and that a variable is just a container that can hold any value. There are 4 main types. We have integers, which are whole numbers. We have floating point numbers, which are decimal numbers. We have Boolean values, which are true and false. We have strings, which we'll cover in a later section. But then we also have different operators that can act on these variables. So the arithmetic operators being the plus, the minus, the multiply and divide. The assignment operators being equals, plus equals, minus equals, multiply equals, and divide equals. And we also looked at how to use the print function with the different variables. So today what we're going to do is we're going to look at testing, and firstly we're going to kind of see why we need testing. Okay, so for the most part, humans write softwares. That's fair enough, but humans also make mistakes. Alright, so you will never come across a developer who hasn't made a mistake programming before. We've all done it, I do it all the time. But how we kind of combat this is by employing early and continuous testing, and this will identify different faults or defects in different software systems earlier on in the coding process. And what we can do is we can find the issues, fix them, and overall it's going to improve the quality of the software. A flawed software product can and does impact a product or a company's reputation, and we need to make sure that any software that we write is safe to use and protects its users from any threats. So some people rely on software in vehicles, medical devices, and other machines, and all of these will keep them safe. So as developers, we do need to make sure that we take this extremely seriously, and if we say something's going to do something, that it actually will. So there was an incident on the Mars Climate Orbiter. Okay, so on a mission to Mars in 1998, the Climate Orbiter was lost in space. And it took a long time for engineers to understand what had happened. So a subcontractor on the engineering team had actually failed to make a simple conversion between imperial and metric units. Okay, so they forgot to convert, let's say, feet into kilometers or whatever. And this small, tiny mistake caused the 125 million orbiter to smash into the Mars atmosphere, and this crippled any and all communications that were sent from the orbiter, and actually caused the spacecraft hurtling around the sun. So, big mistake. Another one was in Fiat Chrysler. And in 2016, they had to recall over 1 million vehicles. After a government investigation, it was revealed that there was a slight gear shift flaw. And this resulted in 266 accidents, 68 injuries, and at least 1 death. So the issue with this is that it did end up causing a death. There was no kind of severe money loss, it was a loss of a human life. So a software update was issued after the recall. However, the update reportedly failed to work, and again a further 29,000 vehicles had to be recalled. In the UK National Health Service, the UK National Health Service admitted to misprescribing medication, to over 300,000 heart patients, and this was all due to a software issue. So System 1, the software which was used to calculate the risk of a heart attack, has reportedly produced incorrect results since 2009. So imagine this. Now, we're relying on a piece of software to determine whether or not someone's at risk of a heart attack, and it has been giving wrong results since 2009, and this has led to patients suffering heart attacks and strokes when they didn't need to. So again, this is something that wasn't tested properly, and now we have loss of life or severe side effects from people having heart attacks or strokes. Alright, so this is why we need a rigorous testing process. So how do we actually test our software? So this is a template that we're going to use to create tests for our software. So a test usually contains at least a title, a description, test data, test steps, expected results, and actual results. Alright, so all it is, the test, or the title, keep it short. Alright, description, small English description of what we're actually going to look at, the test data, and whatever data we need. So test steps, so we bullet point them or number them, what our expected result is and what our actual result is. So then we can see if the test actually passed. So let's have a look at this test. So the title is, we're going to check a mathematical expression. Okay, so using a certain set of data, check that the mathematical expression 188 plus 90 or plus 68 multiplied by 1 plus 3. Alright, so check that this is coded correctly and returns the correct answer. So what's our test data here? Well, it's actually going to be the 188, the 68, the 1, and the 3. Alright, and we're also going to need to know the arithmetic procedures as well. So what we're going to do now in a second is we're going to navigate to repel.it and we're going to create just a normal print statement. Inside of it, we're going to put in this expression, we're going to run the program, and we're going to see what happens. Now, we expect a result of 1024. So what we're going to do is we're actually going to go and run it. So we have print, and we have 188 plus 68 plus, multiply 1 plus 3. So now when I run this, we get a result of 259. So we're after going from expecting 1024 and getting a result of 259. Why though? So now we have to start asking, why did the test fail? Alright, so I know that there was a logical error in the code. Alright, so even though the test failed, this is actually a really good thing because it is a test. It shows that we did something wrong, which is really important. So can we identify this problem? Alright, so I'll give you a second. I'll just go back, have a quick look. Was there anything wrong with our code? Was there anything wrong with the expression? So, if we think of this expression here, the exact same one that we had, 188 plus 68 multiplied by 1 plus 3. That gives us 259. Why does it give us 259? Well, everything happens in order from left to right. So, you'd expect maybe 188 plus 68 and then multiply all that by 1, but that's not the case. So we have to remember PEMDAS. Okay, so we always do parentheses or brackets, or BOMDAS is another way of putting it. So we always have to kind of think of the order of precedence. So what happened in this one was the 68 and the 1 was multiplied together first, and then 188 plus 68 plus 3, and that gave us 259. What we actually wanted was 188 plus 68 multiplied by 1 plus 3. So we had that expectation that it was going to give us 1024. Well, we actually had to kind of manipulate the calculation a little bit more by adding in these brackets. And it's a small error like that that can really cause problems in a program. So if we just go back in and see this in action, so print, and I'm just going to, so print 188 plus 68 multiplied by 1 plus 3. What we see is the first one gave us 259, the second one 1024. So what did we learn about today? Well, we learned why testing is important, alright? So we saw that there's been loss of life due to improper code or improper tests happening. So we need to make sure that the code is safe, secure, and works as intended. What can happen if it isn't tested thoroughly? Manufacturing machines are wrong, there's injury, or there's loss of life and money. Alright, test cases, we use a template. Alright, so a test case will describe the test steps, whatever data, and the expected outputs. And then failing a test, remember, it's not a bad thing. Failing to test is a bad thing, however.